Today we're going to talk about problems in Chapter 9.4, Hypothesis Test for Proportions. Here's our first problem. According to an internet monitoring company in 2012, the company stated that 71.8% of all email was considered to be spam. A system manager at a large corporation believes that the amount of email spam is at 80%. He examines a random sample of 500 emails from his company's server and finds that 382 of the messages are spam. Are the conditions for the hypothesis test met? And the answer is going to be yes. And the reason why is because n times p is greater than 10, and n1 minus p is greater than 10, right? In this case, np is equal to 382, and n times 1 minus p is equal to 118. So now we're going to state the hypothesis. In this case, the hypothesis is that mu, or actually in this case p, is equal to 0.80, and the alternative hypothesis is p is less than 0.80. And the reason why is we're going to check to see if the internet monitoring company is correct. So here's our information that we have. X is equal to 382. N is equal to 500. P hat is equal to 382 divided by 500. And this is approximately equal to 0.764. And then we want to calculate one other item, and I'm going to go ahead and calculate the standard error. In this case, the standard error is the square root of 0.8 times 0.2 divided by 500. Remember, we're always going to use P naught if we know what P naught is to find the standard error. Here, our standard error, when we do the calculation, is 0.0179. It's rounded up. Okay, so now we're going to compute the test statistic. The test statistic, right, is Z is equal to P hat minus P naught divided by sigma P hat, right? And in this case, we get 0.764 minus 0.8 divided by 0.0179. And we get a Z value of a negative 2.011. Now, if we did it on our calculator, we would go to the 1 prop Z test, and we get, when we do that, I think we get Z is equal to a negative 2.012. Alright, so now we're going to go and find a p-value. Right? When we go under the table, or if we use our calculator, we get the p-value is approximately equal to 0.022, right? And so alpha in this case is 0.05, so since our p-value is less than 0.05, we reject H naught. Now, this is what we would have to say. Based on the sample, the amount of spam for this company is less than 80%. And based on this sample, it is estimated that the amount of spam is between 0.721 to 0.801 at 95% confidence. So you'll notice that 8.01, right, is right at the edge of 0.80. So 0.80 is right there at the edge, and it's the upper bound here. And so since our confidence interval is two-tailed versus the one-tailed scenario, we may have the edge, the upper edge in this case, to be contained within the confidence interval. Now we'll go to the next problem. So let's look at an additional problem here. Let's go to the cable company problem. A cable company offered a random sample of 400 customer free access to a new sports channel for 1 month. The company then asked these subscribers if they would pay an extra $10 per month for continued access to the new channel. Of the 400 sampled customers, only 25% or only 25 of them said that they would pay the extra money for the continued access. The marketing manager for the company believes that more than 7% of the subscriber base would purchase the new channel. Do you believe the marketing manager is correct? Test at alpha 0.07. So here we go. We're going to test P is equal to 0.07 against the alternative that P is greater than or equal to 0.07. We're going to test out his theory, right? His claim is that more than 7%. So we have the customer information, right? So X is equal to 25, In this case, n is equal to 400. P hat is equal to 25 divided by 400, which is equal to 0.0625. And I'm also going to calculate the standard error, which is, in this case, 0.07 times its complement, 0.93, divided by 400. And here we get 0.01276 approximately. This is an approximation. Now we're going to do the t-test, right? And here the t-test is z, and it's equal to p hat minus p naught divided by, obviously, the standard error, p hat. Right? So z in this case is equal to 0.0625 minus 0.07 divided by what we got for the standard error, which was 0.01276. So z is approximately equal to negative 0.588. So now we have to find the p-value, right? So the p-value is p-value, right, is equal to the probability that z is greater than negative 0.588, right? Because that's under the curve, right? Our null hypothesis is greater than, so that's why we have to use the greater than for the p-value. So when we look up in the table, actually, we only get the lower bound on the z table, so we have to find the p-value correctly. So the p-value at z greater than negative 0.588, right, is equal to 1 minus the probability that z is less than negative 0.588. Right, and we're gonna go up to 0.59. So this probability, this p-value now, we calculate it to be approximately 0.7217, I think, is what we get. Oh, that's on the TI 83 or 84. I think we get the actual p-value we get from the table is, we had to round up a little bit, so we had 0.224. Sorry for the confusion there, right? Well, we can see for our decision, right, that the p-value is greater than 0.01. So we do not reject. And in this particular case, we say there is no evidence. To conclude, 7% of subscribers would purchase the new sports channel. For $10, right? Per month. So that concludes this particular problem, right? Okay, we'll go to the next one. So here we have a consumer report problem. So we'll go through this one as well. Consumer report study indicated that more than 55% of the children between the ages of 8 to 12 years of old had cell phones. A survey was done in 2012 to confirm this research in a survey of 802 randomly chosen students between the ages of 8 to 12 years of age in 5 states, found that 449 of these students had cell phones. Can you claim that the Consumer Report study is correct based on this survey? So in this case, what we're trying to do is say their conclusion is greater than 55%. We're going to conclude the following, right? The hypothesis is P is equal to 0.55, right? P1 is P is greater than. This is what the consumer reports are. We're going to validate their claim or not, right? So our info is the following. We had X is equal to 449. We had N is equal to 802. We have P hat is equal to 449 divided by 802. And that's approximately equal to 0.56. So we're just going to round it up to there because it's so close to that. And then finally, we have the standard error, which we love to have, right? Or we need in our calculations. So it's going to be 0.55 times 0.45, the complement, divided by 802. And here we get approximately 0.01757. I usually take this out as far as I can because we want to do our test statistic correctly. So for our test statistic, we're going to have the z-test, of course. And let's see, z is equal to p hat minus p naught divided by my standard error, right? There it is. So z is equal to 0.56 minus 0.55 divided by 0.01757, right? And z is approximately equal to 0.569, right? So now we're going to get a p-value. The p-value is equal to the probability that z is again greater than 0.569, right? And so in this case, we're using the table, so we have to go 1 minus z less than or equal to 0.569. And here we get approximately 1 minus 0.7157, which is 0.2843. Right? And I think it's when I use the TI-83, I get 0.2875, so I'm off a little bit when I do it by hand. I always like to show you by hand because you can always use your calculator because you're going to use a one prop z-test, right, for this on your calculator. So let's go to my decision, right? So since my p-value is greater than 0.01, I do not reject. Right? And so now the question is, well, what is my conclusion, right? And the conclusion is based on this sample, right? Based on this sample, there is not enough evidence to believe that more than 55% of students have cell phones. Okay, so that concludes our problems in 9.4. If you have questions, please don't forget to ask in class. Thank you. Bye.